So now we're going to get to break-even analysis. This one's a little easier with the whiteboard, but I think the examples are good here. You're looking at the cost, you're looking at where the costs are coming from. There are things called fixed costs, those things that are constant regardless of the number of units produced. So if I am making a plastic clamshell, there's a certain amount of plastic beads that need to be melted and formed into the clamshell. I don't care if you make one clamshell or 1 billion clamshells, you need the beads, and if you're making the same clamshells, you need so many beads, and at least at today's cost, those beads will cost you X number of dollars. Now, we're not talking about volume purchasing. If I try and go to some plastics manufacturing company and I want to get the plastic beads to melt and form into a clamshell, and I only want to make one clamshell, I'm not going to get a very good deal on it. But if I buy 1,000 pounds of beads or 10,000 pounds of beads, that's a whole different ballgame. So there is the economies of scale, as they say, which again, we'll talk about that later, in terms of purchasing. But in general, we're not talking about that here. We're talking about fixed costs. I need so many beads or so many ounces of beads to melt to make a clamshell, as an example. So there's things that are going in that are fixed, but there are variable costs that vary with the volume of units produced. So for example, if I am making a clamshell, that very first clamshell, I need to make a mold. That costs a little bit. So now my costs change because that mold is going to cost me $200 to make, and I'm only getting 8 cents per clamshell. I got to make a lot of clamshells before I even make up my setup costs. So there's costs, there's revenue. What's the price that the product is sold? The total revenue, the price times the volume. Now this is gross revenue. So if I have a product and I charge $1 for it, $1 each, and I sell 1,000 of them, I made $1,000, right? I didn't net $1,000, I grossed $1,000. I still have to account for the cost that it took me to make those units, right? So that's where we come in with the profit, the difference between the total revenue and the total cost. I take that $1,000 I made and I say, well, but it's cost me $800 to make them. I just made $200. So the total cost is the fixed cost plus the variable cost. I think that's pretty obvious. You add up the costs that I can't change and the costs that do change. Now, I also have to take into account volume. Total revenue is the volume times the price. How many did I sell times the price per unit I sold? And so the profit, I take my total revenue minus my total cost, and that gives me profit. Okay, so you can plug in some numbers, you can play with this, it hopefully makes sense. This is the easy part at this point. We're just looking at how much money did I make. If it takes me $800 to make a stuff that I sold it for 1,000, I made 200. Sold for 1,000. Total cost to make it was 800. I got 200 left over in my pocket. But I can rearrange those numbers for what's called the break-even analysis. You don't need to memorize this, and I won't ask you to do this equation on a test. But if you look at the numbers that we just went through, we can get the volume at the break-even point is the fixed cost. Hold on a second. Price, sorry. The fixed cost divided by the price minus the variable costs. Okay. So the variable costs. Now this one, you don't have to understand it. It's just some relatively simple rearrangement of the equation. If I look at the total revenue and total cost, I can solve for break even. So let's look at an example. My fixed cost of doing this, let's call it a batch order. My fixed cost is going to be $2,000. Regardless of how many I make, the initial setup is $2,000. I'm going to make some rafts, some little cheap swimming pool rafts. It's going to cost me $5 per raft to make each raft. So $2,000 setup, $5 per raft, and I'm going to sell them. The price is going to be $10 per raft. Okay, $2,000 to get started, my fixed cost, my setup, $5 per raft to make, $10 per raft to sell. Well, the very first raft, if I made one raft, it's going to cost me $2,005 to make one raft. And I'm going to sell it for 10. I just lost a bunch of money, right? I lost $1,995 because I only made one raft. So how many rafts do I need to make to break even? So the break-even point, if I use that equation from the previous slide, 2,000, which is my fixed cost, divided by the price minus the variable cost. I need to make 400 rafts. And 400 rafts is not what I want to make, because how much money did I make with 400 rafts? Nothing. I paid my employees. They made their wage because that needs to be in these costs, in the fixed costs of setup, making the mold, whatever. I've got some employee hours in my fixed cost, most likely, maybe not, but depends on the product. But I might have employee hours there. I certainly have employee hours to make the rafts. So they're in there. What about the company's profit? What about being able to turn on the lights at your company, pay the bills? You don't put overhead costs of paying the mortgage on your property or paying PG&E for the electricity to run these pieces of equipment, probably. You can include electricity in your variable costs running the machine. Depends on how you want to do things. I think they most likely fall under overhead costs. But at least this is a really important concept. If 400 rafts is your break-even point, then as a business person, you have to say, all right, how many rafts do we have to make in order to make this profitable? But at least I know if I sold 400 rafts, I didn't lose money. Okay. That's the idea. So let's look at that. Here's the cost line. When I have 0 rafts, it's $2,000 before I even start. I make my first raft, it's 2005. Second raft, it's 2010, and it just keeps going up at a rate of $5 per raft, right? My revenue line, I've sold 0 rafts, I got $0. I'm 2,000 in the hole. Make 1 raft, the difference is 1,995, and this line is going up at twice the rate. It's going up at $10 for each raft because I'm selling them at $10 a piece. So where these two lines cross, that is the break-even analysis, the break-even graph. Okay? And it's important to understand this. It's important to be able to see this. Your cost should go up at a slower rate than your revenue, or you're losing money no matter what you do. The more you make, the more you lose. You can't have your costs going up faster than your revenue, or the lines will diverge and you'll just be going straight into bankruptcy. You've got to be selling things for more than it costs you to make them. And as long as you do that, at some point, those lines will cross, assuming you keep selling them, assuming you keep having buyers for the product that you make. That's another issue. We don't get into that in this class. So the next thing we have to look at is process selection. Maybe I have choices. I'm going to make those rafts, and I can use a $2,000 setup machine, or I can do a $10,000 setup machine. The $10,000 setup machine sounds really good. This guy comes in and tries to sell you on this batch processing machine that will help you manufacture these rafts that your company makes. And he's going to say, your cost per unit is $5. I'm going to sell you this machine that's going to get it down to $2. $2 is a hell of a lot better than $5, right? You can make a lot more money making them for $2 rather than making them for $5. There's a problem though. In order to do that, you've got to spend $10,000 or $8,000 more than you would spend for this other process. $8,000 difference. So if you solve for the volume, you solve for V in this equation, you see I've got $8,000 difference in my setup costs, in my fixed costs. I solve for volume, I need to sell 2,667 rafts. And if my marketing department thinks that we're going to be able to sell 10,000 rafts, go for it. Buy the $10,000 machine, because at 2,667, that's the break-even point between these two processes. This is a different kind of break-even point. If I make 2,667 rafts, it will cost me exactly the same whether I do process A or process B. If I sell 1,000 rafts, process A is better. Not selling enough to make up for the $8,000 here. If I know that I'm going to be selling at least 3, 4, 5, 10,000 rafts, I'm going to sell way over this 2,667. Process B is better. Okay? Really important concepts here, because there's all kinds of people in business who want to sell you the newer, better, greater process. And don't you want to be a company that's doing high volume, higher automation, higher whatever? It costs money to step into those areas of higher capacity, lower cost of production. It costs a lot of money to get into this lower cost of production area, $2 per unit instead of 5. Now, these are relatively small numbers for business, 2,000 versus 10,000. You know, add a couple zeros to this, maybe even 3 zeros to these numbers for some manufacturing facilities, maybe even 4 zeros. But the question is the same. And you just need to know your volume. And that's what's difficult in business. Nobody's going to come and give you the volume. You are going to sell 16,000 of these units. You might fall flat on your face and sell none. You got to follow through. You've got to make the deals happen. Or maybe you're thinking $10 and you can only sell them for 8. The equation just changed. Okay, so business isn't as clean cut as these very simplistic mathematics problems I'm giving you on the last couple of slides here. There's more unknowns and more variables and more problems. Bottom line, with these numbers and assuming you have good marketing data and good confidence that you can sell these units, if you're going to sell less than 2667, choose A. Above 2667, choose B. If you're anywhere near 2667, you need to start looking at your confidence in your marketing information. What's my confidence that I can really sell that many? What's my confidence that the price that we will receive, the revenue, will be what we expect, $10 per raft? Now, in this case, we don't even care what the revenue is for this equation. So process selection, we still have the same idea. At process A, I'm moving in the setup, the starting gate is 2,000. Process B, my startup, my setup, my fixed cost is 10,000. But it goes up at a rate of $2 per raft. My process A, starting at 2,000, is going up at $5 per raft. So it's going up faster. Where do those two lines cross? At 2667. Nobody's saying I'm selling them at $10. Nobody's saying where am I going to make a profit. This isn't about profit. This is just which one is more cost effective to make. Now I have to ask the other question on that previous graph, the break-even analysis. If I chose A or if I chose B, how many do I have to make a profit? Now I need to know how much I really think I can sell them for. Okay, 2 different things. The first graph, break-even analysis, what's the minimum I need to sell so I don't lose money, where I can start making a profit. In that first one, it was 400 rafts using the process A, 400 rafts, and I break even. I can start making money. I make profit on 401, 402. I'm now making profit. This one is just saying which one is more cost-effective manufacturing, which keeps my costs down the most. I don't care what the profit is in this. Once I've made a decision, if I say, I'm going to choose process B because I think I can sell over 2667, I would have to plug those numbers back into the previous example to look at my break-even analysis. Anyway, very important concepts, very important for manufacturing. So let's take a quick break